Here we're talking about the topic dilation. So in this example, it says draw the image of the following segment after dilation centered at the origin with a scale factor of 3/2. Okay, so here's what we've got. We've got a little line segment here. What we need to start with is some more detail. So we want to look at this information. So we're going to label the endpoints A and B. So just label them here. And we know that the dilation is centered at the origin with a scale factor of 3/2. So what that means is that each of the new coordinates of the new line segment are going to be 3/2 times the original. Okay? So for instance, if A is x sub A, y sub A, then the new endpoint of the new segment, A prime, is going to be 3/2 x sub A prime and 3/2 y sub A prime. So all we're going to do is we're going to take the coordinates of the original A and multiply it by 3/2 to get the new A. That's how this dilation works. So if we look at the details of that, then we know that the original A point is 810. Okay, so A is 810, and we want to know what A prime is. Well, A prime, as I mentioned before, that's going to be 3/2 the x sub A prime, which is the 8, and it's going to be 3/2 times the y sub A prime, which is the 10. If we multiply that, then the new coordinate is 1215. That's the A prime. So what we've done is we've just dilated A to a 3/2 centered at the origin. Now we have to do the same thing for B. So all we have to do is take the coordinates of B, the original coordinates of B, multiply each of them by 3/2, and get our new coordinate of B, B prime. That's going to be 18, 9. So now we have the new endpoints of our dilated line segment. If we look at the next screen, we'll see that more clearly. So to get our answer, A prime and B prime, we're going to draw the line segment right here. It's 3/2 as long as the original, and that's a scale factor 3/2 from the origin. Let's look at another quick example. Here our directions say to draw the image of the triangle with a dilation centered at the origin, scale factor of 3/2. So what's our process? Well, it's to label our points A, B, and C, and we've got to get the coordinates of each of those points. So A is 612, B is 1012, and C is 10:8. Now what are we going to do? To create this dilation that's centered at the origin, we are basically going to draw lines from that origin out past each one 3/2, right? But in order to do that, we've got to do some multiplication. So we're going to multiply each of these coordinates by the 3/2. So let's look at that. So what we've got is we want to know what the A prime is. So the A prime is going to equal the 3/2 times the A. So that's going to be 3/2 times both A coordinates. So it's going to be 3/2 times 6 for the X coordinate and 3/2 times 12 for the Y coordinate. So that means that A prime is going to be 9 and 18. We'll do the same thing for B prime. It's going to be 3/2 times the B. Well, what's that look like? That's going to be 3/2 times 10, and then 3/2 times 12. That gives us B prime, which is 15/18. Same thing with C. C prime is going to be 3/2 times the C. It's going to be 3/2 times the X coordinate of C, which is 10, and then 3/2 times the Y coordinate of C, which is 8. That gives C prime is 15/12. So our final answer is going to be when we plot these A, B, and C prime. Let's take a look at that. So we've got 9, 18, 15, 18, and 15, 12. So 9, 18, 15, 18, and 15, 12. There's our new answer for the dilation. That's it.